In today's lesson, we have the change of base formula for logarithms. So it turns out that any base you have, if I have, let's say in this case, log base b acting on some value of m, you can actually change the base to any base that you want here. And the only thing you have to do is you decide the base that you want to change it to. So in this case here, I was in a base of b, and I wanted to go to a base of a. So to do a change of base formula, what it equates to become is log of the base I want of the top value, i.e. your input, your m value, divided by log of the base I want of the bottom. And by doing so, you can always change the base to anything that you want. To look at a proof of this, let's consider the following. I'm going to let x equal log base b of m. Transferring this to exponential form, we have b to the x is equal to m. I'm now going to take log base a of both sides of the equation. Doing so, we get. So now I went ahead and took log base a of both sides of the equation. Notice here I can drop down that x value, and we get. Then I can go ahead and divide across by log a of b, giving us. And you'll remind yourself here that x was actually equal to log b of m. So substituting that in, we get log b of m is equal to log a of the top divided by log a of that bottom value, and then we have our change of base formula here. So you can see here, using your change of base, any base you want, it's just a matter of taking log of the base you want of the top, your input, divided by log of the base I want of my old base value, in this case base of b. All right, let's take a look at some quick examples applying our change of base formula. In the first example here, I just wanted to show you guys, we have a logarithm and the base is 5, so log base 5 acting on 8. You'll notice a lot of the calculators, the implied base is always 10. So if I want to do that, I'm going to take log of the base I want, that's 10 of the top value, divided by log of the base I want of my bottom value. Now again, your calculator will abbreviate log base 10, and it'll just write it as log 8 over log 5. And getting this to 2 decimal places, we get approximately 1.29. So again, by using our change of base formula, we can go ahead and change that base to a base of 10. And now a base of 10 is default on your calculators, and we can actually get a numerical value for log base 5 acting on 8. Let's take a look at another example. In our final example here, we want to solve a logarithmic equation. Notice in this situation, the bases are different. We have a base of 3 and we have a base of 9. So what I'm going to do here is I want to get a common base so that I can apply my logarithm properties. So to do so, what we need to do is get everything in terms of a base of 3. So I'm going to keep this as log base 3 of x. Now to this logarithm, I'm going to do a change of base. So it's going to be log of the base I want of the top value divided by log of the base I want of the bottom value, and that's equal to 1. Now you know here that log base 3 of 9 is going to be 2. And now you can see we can put these together here, and this becomes 3/2. Log base 3 of x is 1. Isolating for log base 3 of x, we get that's equal to 2/3. And now we can go to exponential form, so 3 to the power of 2/3 is equal to x. So therefore, by doing a change of base formula, we can quickly find that the value of x that satisfies our equation is 3 to the power of 2/3. All right, that concludes today's lesson on change of base formula for logarithms. Thank you.